Welcome back everyone. We are now into section 4 of the course. In this portion we're going to talk about classification. In this introduction video I'm going to talk about what are the topics that we will cover in this section. First of all, we're going to give you a really gentle introduction to classification. It's called logistic regression. This has been around for a long time, but the beauty of it is really easy to understand. And we're going to make use of logistic regression and to make some prediction, and we're going to show you how to use stochastic gradient descent as well, so that to show you how the logistic regression can learn on its own without actually using the scikit-learn library. So I'm going to show you and demonstrate to you how you can actually do that by iteration, and that's before we move on to the scikit-learn itself. Why do we do that? This is just to give you a first-hand experience on how to actually how your model actually learn. Now the importance of that is that later on, as you go into more advanced and which is a hot topic right now, such as neural networks, predominantly use or make use of stochastic gradient descent. So understanding these right now is absolutely crucial before you actually move on to neural networks. And the other thing is that although the craze now is in neural networks, a lot of companies, in fact, predominantly still make use of machine learning algorithms that we cover in this course. Why is that? The answer is really quite simple. Neural network needs a lot of data to train it properly. And in fact, one of the Google Brain scientists came out and say, look, you need a minimum of 100,000 data sets, samples, in order for the neural network algorithm to actually learn properly. And most companies do not have that amount of data, quality data, to be able to actually get to that. So by and large, a lot of companies still make use of machine learning algorithms. If you want to go for the last mile, or if you actually have the resources, then yes, by all means make use of neural networks. Anyway, so we're going to make use of the MINT datasets, which is very famous datasets, which contains digits or digits writing by handwriting, digits meaning 0, 1, 2, 3 all the way to 9, and is a classification model that we're trying to train to be able to identify the handwriting properly. So that's really what we're going to make use of before we actually expand to more realistic or real-world data. Not saying MINT is not realistic, it's just that it's been well studied, everyone is really familiar with it. I just want to actually later on, once we get the basics, how to apply these same principles to all the different classification problems that you will face. We're going to talk about performance measures, specifically that is relevant to classification, such as stratified k-folds, confusion matrix, precision recall F1, and also the trade-off between precision and recall, as well as ROC areas under the curve. These are the basic parts that we're going to talk about. But the important part that I want you to actually think about as you actually watch this video and do the practice problems and also the quizzes, once I've actually get it up and running, is this. How would you apply these machine learning algorithms to solve real-world problems? I can guarantee you there are lots of them. So put your head on, thinking head on, as you're actually watching this, and think about how you would solve the real-world problem at your workplace right now, rather than wait until you actually have fully mastered everything. So the best way to learn is applying it right there and then. If you're stuck, hey, always post the questions, there's never any silly questions, just post it. I'm sure someone will actually come around to answering your questions. So let's get into the course right now. Thank you for watching.